Welcome back, everyone. I see it's exactly at time, so we're making us up for 2-hour session with the theme of validation. So first hour and a half approximately is IDS, and then the last half hour, Johan will give us an update on the bSDD validation service. First hour and a half will be hosted by Sara with the help of Robin. So I think Sarah's already sharing her screen. So feel free to take it away.
Thanks, Leon. First of all, hi, everyone. Thanks for having us tonight. We're going to talk about IDS, information delivery specific, and what we've done so far. This is just a standard safe harbor statement of bSMART, basically mentioning what we're talking about might be a bit forward-looking, and it represents our view at this stage, and these might change in the future. So the agenda for tonight's session, we start with talking about the goals of IDS. We give you a little bit of history and outline of the IDS process. We also have an example there. And then we shift to live demonstrations. We've got 3 demonstrations. And you have a chance to ask questions or if you have any comments there. And then we'll talk about IDS 0.5.10 class diagram and some new use cases, the current issues and next steps. Then again, we'll have time for questions. So talking about the goals of this project, one of them is to be able to specify the requirements and then to be able to link it to URIs. We want it to be computer interpretable to allow for automatic validation of IFC. And also it should be based on industry standard technologies and be extendable. So the IDS process, over to you, Robin.
Thanks, Sara. So this is the schematic diagram that was put together at the start of the IDS project. So we start in the top left-hand corner. Next slide. So this is the client. The IDS is aimed at allowing people to specify what information they need to see in the data that they get back when modelers are creating BIM models within their projects. So the client creates an IDS using templates and so on, and then this becomes a specification which could be contractually enforced, and this IDS specification is then sent to the modeler. Next. So the modeler then has the responsibility of verifying that they're able to deliver on that data specification. So this, hopefully, all the capabilities that are built into the software they already have, and maybe their libraries, or they may need to do some work on extending their libraries in order to meet the client's data requirements. So once they've verified that they can do all of that, they then create the model and make sure all the data is in there. Next. So once they finish this, then they can use the IDS specification to validate the data they've created against the IDS requirements. And one of the longer term goals of the project is to then allow this data to be enriched from the bSMART data dictionary project. Next. So once the modeler has actually validated their output against the IDS specification, and this is then exported across as an IFC model, and also linked into the BCF if there are any validation issues with the model. So this is made available to the client. Next. So this could be sent across as a file, or it could be distributed using an API or whatever. And then the client is then able to validate the data against their IDS specification. And ideally, we go next. And we have a happy client if all of this goes well. if you actually reflect a little bit, this model isn't actually that unique. This is very similar to the process that was envisaged for COVID. So while the overarching process concept is similar to COVID, there are obviously some IDS specific requirements. Next. So why IDS? Well, IDS was started back in about 2020. There are already some technologies within bSMART that have been used, and IDS is exploiting some of these. We don't intend to go into detail on that. Leon recorded a video online at one of the bSMART presentations. It's available at that URL, which describes a lot of these technologies. And if you want to check up on what he said about IDS, then that starts about 12 minutes into that video. So if you want to find out more about the founding, have a look at that, and hopefully that will resolve most of your questions. Next. Okay, so stage one was led by Cyril Pennever, and this was about actually making sure that this IDS concept would work and gathering the data requirements around IDS, actually, sort of doing paper-based workflows and so on to make sure that it was actually worthwhile going into the implementations. So Cyril chaired the process meetings over about a year, where they improved the applicability of the IDS concept. They identified a range of use cases that demonstrated that there was a need for this from industry. These use cases were then made available as the foundation of stage two. And this was all done through a series of international online meetings with overall over 40 people were involved in these discussions. And stage one finished in early 2021, if I get the date properly. Neither Sara nor I were involved in stage one. And then we were invited to lead stage two of this. So next, Sara. Oh, sorry, yeah, before I go into that. So this is a list of the use cases on the left, and developers of the use cases across the top, and then the capabilities that were identified against each of those use cases that needed to be implemented when we actually started implementing the IDS. So next slide. Okay, so stage two, this was intended to start in the middle of last year. Unfortunately, I had an accident which slowed us all down. So it really kicked into gear in about November of last year. So we've been working on this for less than 6 months. And the idea of tonight for us at least, presentation was actually to update people on where we are. So stage two is about implementation. So we is the royal we here, us and the various participants in stage two are implementing and testing use cases. Some of them are some of the use cases that were developed in stage one, and others are use cases developed by some of the implementers that match either their needs or their potential clients' needs. And this basically involves working through the implementation issues that people discover as they're actually cutting the code to test out these ideas. So the initial goals of stage two implementation, number one was to define the units and the data types that we're going to support in this initial phase of the IDS implementation. So one decision was made there is that we would work basically with the metric units as the base units for all data exchanges using IDS, and then it would be up to both the rewriting and the reading software to convert from metric units if so the imperial units were being used. And we were actually defining a particular unit is to use for each physical measure, so that it's up to, once again, the writing and the reading software to convert from, so kilonewtons to newtons, and then back again. So we under normal circumstances, there'll be a default having a particular unit in scale. We're also concentrating on mapping the implementation of materials within IDS to the implementation of IFC material to ensure that we keep the units, keep the capabilities of exchanging the material definitions in IDS. We've also started on mapping assemblies within IDS. So we have one component as part of another component. Currently, the proposal there is that within one IDS definition, then one component can only be part of one assembly. If one component needs to be part of two different assemblies according to a client's requirements, and that would be defined as two different IDS specifications, which would check the different aspects of that. And in the process of these implementations, then we're creating more examples to, number one, stretch people who are implementing with coming out with new concepts, but also come out with examples that clarify any issues that have emerged during the implementation. Next, Sara. Okay, so the project philosophy, or at least Sara and myself are applying to this project, is a quote that's attributed to Albert Einstein, but so everything should be made as simple as possible, but no simpler. So this stage is about implementation. So we don't want to solve all of the potential problems that may be met in encoding and decoding IDS. We just want to cover the identified real-world scenarios that we're doing. And if someone comes up with a possibility, a question about some implementation, if we can actually build a real-world test case that encapsulates the issue and allows for test implementations, then we'll defer that issue until we can actually define a real-world example. So we're actually focusing on delivering real-world capabilities. We're not trying to replicate any of the activities in international standard organisations where they do actually try to cover as much as possible, every possible variation. We want to be very applied and the focus on delivery, and ideally the results of what we're doing will then feed into some of these international standard development projects. Next, Sara. I'll hand over to Sara.
Thank you. So having fire resistance buildings is one of the main aspects of building design. The image here relates to Grenfell Tower. I'm sure many of you already know about that. So this was a catastrophe that happened because something went wrong at many different levels. And we had a similar problem in Melbourne, Australia, where cladding caught fire. But fortunately enough, they could contain the fire quite early, so the consequences were not as catastrophic as Grenfell Tower. So basically, the reason that we've got this example here is to show the IDS is not just about software tools, it's about the decisions that affect people's lives. So for example, when we're talking about fire resistance and fire rating, in many countries, we've got a single number for fire rating. But here in Australia, we use fire resistant levels. And there are 3 different levels that are defined in the building code. We've got a structural adequacy, which refers to the duration of time that a structure withstands its structural capabilities, basically. Then we've got integrity, which is the duration of time that before a component collapse and lets the fire or hot gases or smoke pass that component to other parts of the building. And then we've got insulation, which is about the heat flow before the heat flow can go from one part of the building to, for example, other side of the wall. The screenshot from at the right-hand side is from Building Code of Australia, which shows concrete beams with different thicknesses and different fire resistance levels. We're not sure if many other countries use like same level of, so different numbers for fire resistance. Here is where IDS can be used to extend the data in BIM software to allow customization for countries like Australia to still be able to check for the compliance with the building code. And another thing is when we're talking about fire resistance, these numbers are assigned to different components. When we pass a certain size in building, we need to have different fire compartments to contain the fire within the area that it happens. And then we've got different fire barriers in those compartments. With IDS, we would be able to check the fire resistant levels just for those fire barriers, for example, we'd be able to just assign those fire resistant levels to the fire barriers rather than every single component and check it against every single component where it's not really needed. And that's something that is in the scope of IDS. And then this image here shows the required distances from the boundary for residential buildings for external facade for the fire requirements. This one is out of the scope of IDS because we normally store the files of site boundary and site plans from the files from the building. So currently this can be done by available softwares like Solibri Model Checker and things like that, but this is not something that will be covered in the IDS. Now we shift to presentations, the demonstrations. The first demonstration that we've got is from Artur. Artur, are you here?
Yes, hello, I'm with you.
Yeah. So will you do your presentation live?
No, if you could show the recording because I'm losing voice, sir.
Yeah, sure. So I'll just play your recording.
But I can answer any questions if you have later.
Hello everyone, my name is Artur Tomczak and I'm a PhD researcher at NTNU University in Trondheim in Norway. And I was invited by Robin to present to you the result of my work on IDS implementation. This project was a part of Google Summer of Code program, which is happening every year during summer and is funded by Google. And I was lucky enough to be mentored by Tomáš Križnen, who is the author of IFC OpenShell. And my task was to implement the IDS and also to allow it to validate IFC files and create PCF report files out of this validation. And I'm sure you are already aware of what IDS is. You were already told before. I will just quickly show that all the progress you can track on the buildingSMART IDS GitHub repository. Here we describe the issues that are currently being discussed and all of the progress. And the schema itself can be found on buildingSMART.org websites. And I will share with you all the links in the chat in this meeting. But when it comes to my Python implementation of IDS, we also have a discussion on this OSArch community forum in the blog post called IDS Information Delivery Specification, which you will also find in the links. And here we try to discuss the progress, but also if somebody has any questions, you can post it here and we will try to answer you quickly. So that's it. So for those of you who are not aware what IFC OpenShell is, I will quickly introduce it to you. So IFC OpenShell is a open source set of tools created by many contributors, as you can see here, and it allows, for example, for parsing and creating IFC files, but also many other features. Here you can see a list of them. One of them is Blender Beam, and some others are also integration with bSDD. But what I'm involved in mostly is IFC OpenShell Python. And if you go to this folder, to IFC OpenShell, you will find here the IDS.py file, which contains most of the work I did during Google Summer of Code. And I will not show you all of the code now. You can have a look yourself if you're interested. But if you want to implement it, I recommend you to go to the API documentation, which is also in the links. And to show you, to demonstrate how it works, I will now go to the code. And in here, you can see the demonstration how to create a simple IDS and how to use it in Python. So first, you need to install and import IFC OpenShell. And from there, you need to import the IDS object. And let's run this code now and display what we have here. So I have just created the IDS object. If I now type I can have a look at this object. It is already compliant with IDS in version 0.5.8, if I reckon. And here you can see how it looks in Python. So you have the info object with title, date, and of course here you could have also many other attributes like the version or description. And then you have specifications. Here I have only one specification with index 0. And this specification contains, of course, the name, IFC version, a use attribute saying that this has to be required. And also it has those two required attributes, which is applicability, where we define the terms, what needs to be fulfilled for this object to be applicable to pass this specification. And after I run the next line of code, I need to open it again. I can see also that it has not only applicability, but also requirements. So all of the requirements that our IFC object needs to pass to be compliant with this IDS specification. So in this example, I'm asking for a property called test with a value test from a property set test that can be in any location. So it means it can be both in the instance and type of the object. And to be compliant with it, the element has to be of the entity called test name. And this is not entity that we can find in IFC schema, so none of the objects in models will pass this. So yeah, this is just to show you how it works. If we want to create a bit more complicated and advanced IDS, we can also do it. Here I'm showing example how to add restrictions to our properties. So here, instead of asking for a test value, I can define the regular expression pattern. This one doesn't make sense. It's just showing that you can use various characters in here, but this is how you add it. And then after you have created your IDS object, you can also validate your IFC file, which is exactly what I will do right now. And instead of creating new IDS in Python, I will now just open existing IDS file from path. So let's do it now. I also open IFC file, not only IDS. And before I run this line of code, which is the validation, let's quickly display how those objects look here in the console. So if I type IDS file, I see that I have this IFC IDS object with specifications and so on in here. And if I type IFC file, I have IFC OpenShell IFC file with all of the content of IFC model. Okay, if I run the validate function now, it printed in the terminal here, it printed the result of this validation. Maybe this form is not user-friendly, but I will show in a moment how we can improve it. But it's giving us the result. So first I think out of 5 items here is saying that the result is false because the given instance with entity name IFC wall, we expect property test parameter in test property set with a value test value, but in our model, the wall called test wall number 1, name 1, doesn't have the test property set. Yeah, so with this plain text explanation, we can track where is the mistake in our model and we can improve it. But if we are not satisfied with the Python console log of the errors, we can also create a PCF report. And it's not all of the options we have because IDS Python implementation also allows us to create CSV files, and there is possibility that we will add more export features in near future. So let's have a look how to create a PCF report. I will delete what I already have prepared before. Here is the output folder where I want to have the report. So let's run the next lines of code. I need to specify the path of the file. I need to add the logger, which is a normal Python way to do it. In the logger, I need to specify PCF handler and add properties such as what is the project name and author and where is the file located. And then when I run the validation, it should print here, it should create here the IDS report PCF file. If I simply open it, I have it on the different screen. Let's have it here. It doesn't tell me much because it's in the zipped version. But if I want to open it with Notepad, let's first unzip it. Okay, here I have all of those 5 results. Let's open first of them. Okay, this is the viewpoint created, so it's showing us where is the problem. And here is the markup itself. So we have the title that IFC test wall name 3 doesn't have, this is a grammatical error that I need to correct, doesn't have the test property set, so it's not compliant. And if you want, we can open this PCF in any of the dedicated tools for it that you prefer and display the results. So this is how to create a report. And at the end, I would like to show you also the user interface that I started to prepare. And this user interface is available on the temporary website called Tomczak Python anywhere.com/create, which you can also find in the links. And this is work in progress, but I wanted to show you how you can use this Python implementation in your workflows. So if you go to this website, you will see this page. And here you can specify each of the features that is asked if you want to create IDS file. I have here sample properties defined. So I have one specification that is called file requirement specification that is asking for IFC walls of predefined type cladding to have a material called timber, and this also should have a property called strength class from set structural, and the value needs to be equal to C30. I can also add more specifications. This is not a problem. I can select another IFC element. For example, let's have a IFC wall that should have a, let's say, property called from set ABC of value XYZ. And at the bottom here, you can see this plain text explanation of our specification. So you see that I just created specification that is asking for IFC walls to have a property ABC in set ABC with value XYZ. And if I want to download, let's go to the top of the page and click download IDS, and it will allow you to download your IDS XML file. Let's open it. This is how it looks in IDS version. If I go to the bottom, I will see that it created this new specification called new specification that is asking for IFC wall to have property set ABC with property ABC of value XYZ. So as you see, this is one way you can create IDS. It doesn't allow yet for the validation, but this is desired to be added in near future. So if you need it, please contact me. You can find my contact information at the bottom of the page, and I hope this is showing you one of the possible use cases for how you can use and implement IDS in your workflows. Thank you very much. If you have any questions, I'm here available online. Thank you.
Okay, thank you. I think we'll leave the questions to the end of the demonstrations. Now we shift to the second demonstration, which is by Claudio, and it's about IDS editor. Claudio, are you here?
Hello, hi, can you hear me?
Yes, can you? So I'll stop sharing so that you can start sharing.
Okay. So my plan is also to show an editor today. The quick agenda is to talk about IDS and our view of implementing it at XBeam. And the tagline is verified information flow. So yes, it's as was mentioned before, we are discussing information flows. We're not discussing strictly evaluation of building properties and qualities. So not code compliance, but information flows. So today I'll be kind of showing the code that we have available already and what we're planning to deliver in the coming months. We have an open source IDS implementation as well, which we try to keep on the bleeding edge, which means that we normally are only a few days behind the schema changes. Then the demo of an online editor that we have that shows more or less what was just previously showed, but perhaps with a little bit more nuance. And then we'll be discussing the verification library available and the different ways in which we are making this available. And I think an important difference between what you saw before is that we are working on the .NET framework here. So this is not a Python implementation, it's a .NET framework implementation that I'm going to be showing. So it's available until we kind of, we are in alpha, as you know, we are in alpha, as you might imagine, because we are still working on an alpha or beta version of the specifications. And you can see the repository at my personal GitHub homepage at this address, which you can see from the QR as well. But once it's going to be kind of graduated and released, then it's going to be moved to the XBeam team page. So what is it? It's an open source .NET framework implementation of all the extended features that we are planning to have in the information flow verification of XBeam. The code is, we are, because this is about data assurance, we are doing the utmost to make our own implementation test-driven as well. So we have a very robust test suite that we are developing alongside the code, and that we run frequently to see that any changes that we make to the library complies with the requirements that we specify. We have a fully featured and tested import-export functionality to buildingSMART XML version of the IDS, but we also have our own JSON schema that, as I said, kind of looks a little bit forward to perhaps features that will be available in the next version of IDS, of the official IDS version standard. And then on top of these, we have a few helper functions that enable us to like a bit of a richer editing of the IDS content. So we injected in the library, which is also, which makes it available for any UI that you might want to create, knowledge specific about the IFC schema and standard properties and everything else that we think might be useful for third-party implementations. So this is a library with no dependencies, so it's completely standalone on .NET standards, and it's going to be released is in NuGet packages for Net Standard 2, Net 5, and if there is a request, perhaps due to increased inefficiency in Net 6 as well. So I'll be able to answer questions around it if you want further, but then the next, the large part of the demo that I wanted to go through was the IDS editor as a playground that we have made available online as well. So this is the QR to get to it. Otherwise, you can go to xbeam.it/xids. A caveat, because as I said, we have extra features in our verification. If you only want to stick to the standard buildingSMART kind of feature set, you just set BS equals true, and that keeps you on the buildingSMART compatibility form. So what is this UI? I mean, we'll see it shortly, but the point is that it's a single page application written in Blazor, and it's a WebAssembly and compiled to WebAssembly, which means that basically it is always running on your own client. It will never reach, anything will never reach our servers. So I think, if you want to play around with it, you can feel free that no information that you add to the specifications will ever be lost in the communication or captured by anybody, because everything is happening on your own client locally. But this comes with a caveat, because we don't ever see anything, and so this data is not transferred to us in any ways. Make sure that before you leave the page, you save your content, download your content to a local file, otherwise it's all lost. All right. I'm not sure whether to go for a live presentation, because live presentation is always tricky, but I hope you can see my screen.
Yes, we can.
Yeah, okay,
Yes.
so this is the live version. As I said, it's xbeam.it/xids with a pattern BS equals true. First thing, you have to agree, mostly as a reminder that everything will permanently be lost if you clear and move out of this page. So once you agree, you're presented with an editor that allows you to start adding specifications or drop your previously saved files here on this Dropbox to save them. So if I go and get the demo file, I just drop it here, and all the specifications are going to be loaded. And for the meantime, I'll just refresh so that we start from an empty page. So I think it was kind of mentioned already, but it's worth going through it again, perhaps. So IDS is just a collection of specification clauses. I can add as many as I want here, and each of them will be defined internally with a few properties and instructions and so on. But basically, it is a pair of a group of facets that define the applicability and a group of facets that define the requirement. And there are a few more information like titles, copyright metadata, version metadata, and so on and so forth. But at the moment, the editor does not contain that part of the schema yet. So how do we define applicability? Well, by adding a number of features or of facets to define what we're interested in. Let's make an example. So we can try and say, start saying something like solid walls are safe, and solid walls, and that means that solid walls have fire rating. Okay, if I go back to my page, I can just basically do that by saying identifying ways in which I want to determine what are my solid walls. So this is a type facet. So it's basically a way for us to identify portions of the model by IFC type. And so I can just either type the name of the type here, or I have a helper instrument. So whenever you see this magnifying glass next to a facet, it's one of those helpers that I was mentioning before that makes itself available. So I can say, I can type wall, and a list of all the parts of IFC that contain the wall comes up. So I can say, well, a solid wall. So this contains not only the types, but also the predefined types in the library. So you can make, it's easy to get it right. And so if you wanted to say something like that the solid walls have fire rating, I can go and add a property of fire rating with the property set, the property name, and extra features. Again, we have an helper here. So fire rating brings up all the available definitions of properties in IFC. So wall common fire rating is what we are after here. And now this would mean that the property is just exists, but we can add more constraints by setting something in the value if we want. So yeah, basically we can start naming portions. So this is something that could be all solid walls, and this is our R have fire rating close. If I compress this, then the system kind of gives me a quick summary. Okay, so beyond applicability and requirement, which we have seen, there is the concept of optional, required, and prohibited, which has to do with cardinality. So if something is optional, if one specification is optional, means that I don't expect any specific numbers of walls to be found in the model. Required means that there is at least one. Prohibited means that there should be no element in the model that matches the applicability side of the specification. What else? Well, I mentioned the helpers already. So whenever you have these magnifying glasses, you have access to those helpers, and they at the moment are available for types, properties, and property sets, and attributes and their names. And any facet is built by using one of these 6 elements, which we just discussed. So type, classification, a property, a material, an attribute of a type, and part of, which means whether something is part of a group or a system or is a component to another element. An assembly, I mean. What else? Okay, so we discussed already these helpers. I already showed how this can be brought up. Maybe a nice thing to show is that in the live demo is that if I'm looking for some particular properties, I can use the helper here, which has this kind of smart camel case helper approach. So if you're looking for wall common fire rating, you just type the initials of each of the words, and that quickly brings up just a few matches. So making the editing much faster than other ones. So going back to the demo, what else is there to say? Yeah, I think something interesting is that we envision that the specification can be developed progressively. So people might initially say, well, we know that structural elements should have a quality certificate document attached, so as a requirement expressed in an informal way. And so we can start defining structural elements. And so the idea of structural elements and the idea of point to a quality certificate as two facet groups. But you will notice that they kind of have a warning here to make sure, to kind of remind people that these concepts will have to be actually implemented with specific, by some of these specific combination of facets. And interestingly, then the system will kind of remind us in the compact form as well that these with these orange marks, that we still need to work on those to make them applicable. But I think it's an important aspect to consider the practical usage of these methods. Then we have a few more helpers, as in sometimes we provide colored warnings for facets that are not quite complete. So it doesn't make sense to have a type facet which has no specified type, just as it doesn't make sense to have a property type, a property facet which doesn't specify at least property set name or property name. And so these are, even if they have kind of been drafted, they are invalid. And so the warning tells us that there's still work to do to make that valid. Now, another feature of our interface is that we can reuse facets that have been previously been defined, actually facet groups that have previously been defined. So we have kind of a lookup mechanism, maybe it's worth showing, that allows us to achieve just that. Let me refresh this page and load the demo file again, so that I have like an initial library of elements to display. And if I can add a new specification, I can say, well, what have I defined already around walls? Well, I've defined two types of walls already, solid walls or all walls. And so just by doing that, I just easily and quickly bring up a definition that is already available somewhere. But again, because this is reused in multiple parts of the schema, then it's worth having this little warning here on the corner that reminds us that if we make any changes here, this will affect the other instances of the same facet group as well. Now, of course, if you're talking about a single wall, this might be or seem redundant, but there might be like more complex situations in which perhaps I have a combination of facets. So this facet requires me to have a wall which has a specific fire rating and a given attribute name as a single facet group. So this is called helpers available. And I can quickly go back here and say, no, I want to bring up the helpers available, and all the three facets come at once. So this makes for a speedy editing of the IDS. And then going back to the presentation to see what else was to say. Well, this is just the same thing that we just saw and the warning that we just saw. So finally, we have seen we have this opportunity to define more complex constraints. So whenever one of these constraints is specified and you see a little lock around that, it means that it can either be a simple string or a more complex constraint made of enumerations or patterns or structural properties, similarly to what we have in the XSD format. So we are actually taking the same approach in the IDS to define those constraints that it is used in the XSD definition of types and values. And so I can quickly demo it, but you can see an image here on the right hand side. So the property name in this kind of scenario can be one of these two values. Sorry, yes, the property name can be one of these two. So this is a requirement that is fundamentally saying that the model expects within a property set name called my own specified set, either or both of these properties, and this will be fulfilling the requirement. But we have, if I go back to the live demo, which I hope you can see here, whenever I defined such property, such constraint, say on a property value, then I can define an exact value or a pattern value or like a structural constraint such as an exact length, so length of the string, minimum length of the string, or maximum length of the string. So sometimes you adding values, so 1, option 2, and you can collapse this, but you're going to get the warning to say, well, look, you're trying to collapse this to a simple constraint, so this is going to be simplified. So yes, please drop it or keep it. That's because if you start typing IFC wall here and oops, sorry, this is not the right thing, but IFC wall here, regardless of the meaning of it for the time being. If I see the constraint, so the constraint can go back and forward as long as it's a simple string. But if you start adding new values, you're going to get a warning when simplifying it collapses the richness of it. Okay. So finally, I think an interesting thing to see would be that we have a mechanism for actually displaying the same content in a much perhaps more compact form. So the same content can be displayed in grid view, and here we have all the applicability facets, and they are kind of crossed with all the requirement facets. And you can easily add more to say that all structure elements should have classification by clicking here. And define that structural elements also have any properties. And if you go back to the previous view, then you'll see them added to the list in a fairly quick and kind of intuitive way as well. So I think what we've done is to consider carefully the user experience of the editor, of the people that are working with us, and try to make it easy for them. Now, of course, on the side, we also have a verification library, and we have like the verification classes available, either in interactive environments for reporting, for command line interfaces in order to make it easy to embed in clear workflows. We have an interactive viewer that allows people to kind of run the verification and color the model, considering the various configurations. And yeah, this basically closes the presentation. So if you have any questions, I'll be happy to answer, I guess, later. Is that right, Sara?
Yeah, thank you very much, Claudio.
Okay, thank you. Thank you all.
You can stop sharing your screen.
I can stop sharing. Okay.
Thank you. So we've got one more demonstration left here. So the next demonstration is by Peter Kompolschek. It's on the software developed by Rainer and Peter. So Peter, if you are here, I'll pass it to you.
That's cool. I'm here.
Okay.
And I will start showing my screen. Start. Okay, you should slowly, but you see the screen now. Do you?
Yes, yeah.
Okay. So what we have here is something that starts right after what we see now, because we are not defining the IDS, but we are using it in this software. Maybe to explain a little bit, what we have here is BIM, it's a software which is an IFC validation, modification, editing software. So we can like edit all information that we get from IFC models in this environment. And yeah, that's basically what we do. So it's an authoring tool for IFC files. And what we think is very important about this is that we read IFC files and we produce IFC files. So we are always in this open data environment. So we have no closed files systems that we produce. Okay, what we have here is just a project. This is a real project. It's a building, and we want to validate this building against an IDS. So we have a menu for loading IDS files. I did this in advance just to be a little bit faster. So we have like the title of the the IDS file, which is called classification of the Austrian standard B1800 and German standard 277-2. And so it's the file is called IFC spaces versus DIN 277-2. And so, and as you see, we have a lot of specifications in this IDS found. And what I tried to show here or prepare here is that you can see how we use IDS like to make some basic checkings if the requirements of the information is met. Then we go further in detail, and then we go even more in detail and find some special classified, for in this case, rooms in our model. So the first thing we have to do is like to select one of these specifications from the IDS. I started the first one. Immediately the system starts to like check if the objects are available. So we see now we have in the object, in the model 61 objects of type group, of type space, IFC space. And we see that from these 61, 42 are meeting the requirements. The requirement is that there has to be a property called, that's German, unfortunately, it's called a group of usage after DIN 277-2. And it's on instances, so it's the same as you saw before in the other two presentations. And we have here now 19 elements that do not fulfill the requirements. So this is 42 IFC spaces having a property required, the others don't meet the requirement. And what we can do now here is like, I can select the elements that are meeting the requirements, or I can check the other ones who are not meeting the requirements. So, and I can isolate them, so you just see the elements that are not meeting the requirements, which is something that we really need quite often in validating our IFC files. The next step that I suggest is to like go in to 772 classified. So this is a specification that says, okay, I want to have like, now first we have met the basic requirements. So we know that we have IFC spaces that have the requirement of the property fulfilled. And now we check if the property has values that are from an enumeration. And you see here the enumeration, which is like German. You will forgive me, but it's like different room types that are standardized by German standards. And so we see that we have in this model just 5 elements, 5 of these spaces are fulfilling the requirements of this specification. And you see these are the rooms. And then the majority, which is 56, do not fulfill our requirements, which is the majority. And so that's very interesting. So just to show what we are using that for is like to say, okay, we have these 56 elements that do not fulfill the requirements and we isolate them. I hope I did it right. Yes. And if I go to one of these elements, I can go here and see now this is the information of the element. So you see, this is a whole lot of information, and I hope I prepared it correctly. So we have like here the reduction to the different elements that we have. So this is the room that's meeting not meeting the requirement, and on the other hand, we have the rooms that are here. Like so, we see for each of the rooms the information on the different informations regarding. So we have here the usage goes Lager and Vertafel. So what we can do now, if we feel like this is a wrong classification, we can go here. And because we have an enumeration here in the IDS, we have the same enumeration in the model, and we say, okay, no, we want to change this classification from what it was to what it is now. And so we have changed that, and this is one of the qualities that we see in the IDS implementation here in our software. And this goes on for like other classes, like we want to see if there are requirements. It's narrowing down the information of the IDS in the software. As you can see, this is very flexible. So I go to another model that we have with us, which is a smaller one, which is more infrastructure-like. So what we have here is an infrastructure project, and we see that this is like some walls, protecting walls, and we have some tendon anchors. And what we see here is that these elements do have, again, a lot of information because we are collecting information here. So we are applying documents and other things to these elements. And what we do with this software is we are doing the accounting of the building site. So you see that we have like a coding system, which is what we have here in Austria. So this is just a code book, a standardized code book, which is number based. So we see the number 1923 whatsoever has that's a type of concrete that we use for this, and we see the amount that is like in the project, and you see we have a build amount which was 8.6 cubic meters. No square meters, and so on and so on. What we can do here now, we can now check to get another IDS, which is called the check of the accounting. And so this is a short IDS that we created. We have just 2 different element types. The one is for the IFC wall. And you see, okay, we have 2 walls that are, the question is that we want to check if the value of the AVA build, so this is the timestamp that we have here, has to be between the August 31st and November 30. So this is a time span that we created here. And so we see that 2 elements are within this time span and the other students fulfill the requirements. And so this we can do for anchors and everything else. So it's always the same process. What we have here is, because we felt it's good to have a report in immediately, which is not the BCF report that we saw just from Artur's presentation before, which we are working on because we have BCF in the software, so we will do a BCF reporting tool too. But so you see, okay, we have a report of what we did here, and you see which elements are fulfilling a requirement and which do not fulfill the requirements. And again, we can create like a sum of those elements that we selected, and we see that we have in total, we have like for the information, we have like here all the information like summing up to the totals that we created in a time span according to our IDS requirements. Okay, that's what I want to show you in short, because I thought we don't have too much time. And so I was speaking very fast and showing very fast. For questions, don't hesitate, just do.
So we use IDS also for checking of processes, not just for checking of models. So it's quite a useful thing.
Maybe we can say we are happy using it because we are doing things that were not basically intended with IDS, but we felt it's a good tool to do that.
Thank you very much. Thanks for the great presentation. Now we open the floor for any comments or questions about the demonstrations that we just saw. If there is any comments, questions, please feel free to ask.
I have a question. What is the intention for where these IDSs are created? It's basically everyone's supposed to create their own IDS editor, or is there intended to be a buildingSMART IDS editor, or what's kind of the view there?
Well, I think the goal of our project and our implementation is to encourage the various software vendors to include IDS capabilities within their software, the authoring software or checking software.
Basically, the idea to standardize the whole thing, to have some standard where you can specify requirements for the model. So that's, I think, the basic idea.
There's also software suppliers that are focusing on defining requirements involved in a project. So bSDD, for example, Plannerly. So those people are also following the project, and we hope that they also would support IDS as export from their tools.
Yeah, and we'll reinforce we've only got 3 of the current implementer activities shown today. There are other people working in this area.
Okay, I have a follow-up question. So, I mean, it's obviously, well, it seems as if an IDS by itself would not be sufficient to define an IFC, right? You'd have an MBD and the IDS would kind of be applied on top of it to have the rules for it. It did seem as if there was the ability to prohibit things. So could you have an IDS that prohibited walls from your export, and would you expect the export to be modified as a result, or would you expect that to be checked and say, hey, you have walls?
That's not a use case that I envisaged in the project. My personal concept of IDS is about specifying what information we need in a model in order to be able to meet further requirements. So it's a way of defining what we need to ensure that the models represent all the data needed further down the process.
I think the answer to the question is yes to both, Angel. So we hope that authoring tools use the IDS filter or the IDS configuration on exports to also make sure that they do not export the prohibited entities and properties. But if they do, at least it would indeed pop up during validation. I think that the example of prohibiting walls isn't something that is being used a lot.
Really
but,
makes sense, yeah.
But we do see a lot of requirements that say they don't want this self-made property sets that come along in a couple of exports. So most of the use cases are focused on that.
We have a question from Stefan.
I'm not sure if Peter wants to answer previous question first.
I think now, like playing around with IDS in projects, I think it's as Leon said, it's very likely to be capable of doing this, that you create a definition which is a standardized definition for like a country which is small like Austria, where you have like for a requirement like for a permit or what, that you say, okay, you have a quality gate which is like defined by an IDS, and to export the information to an IFC or restrict the IFC into the information that is seen in the IDS. Which is maybe an answer to Angel's question. I feel that's a good motivation to do it. And besides being a quality checker, a quality gate in projects, I think that's interesting.
Thank you, Stefan.
Yeah, I have two questions. One is for Peter, that said that he's sort of abusing IDS to make this date comparison. So I'd like to see what exactly is he abusing. But also the second question with the project itself, what is the scope of IFC, of IDS? What is the scope? How much of IFC can I check with IDS?
I think you can check everything, can't you? I mean, it's basically about alphanumeric data. It's focused on alphanumeric data. That's one of the restrictions I would say. I mean, it's not about geometry and these kind of things. It's basically focused on alphanumeric data that's in the IFC file.
Yeah, the used facets are entities, attributes, properties, classification references, and materials.
Yeah, exactly. So that's.
I think it also relates to Angel's earlier question. So yes, it is possible indeed that you, that you parse the IDS before your export of IFC, so that you have information on some sort of a property mapping. But ultimately, I think the scope of IDS is much more on the user side, something that the user has direct control of, which properties are populated for an element, what kind of material names do I use throughout my project, and that indeed, well, what used to be MVD or what still is MVD tied in much more with the exporter logic, the domain, the mapping routines that the exporter would use. So that was much more on the software implementer side, and I think IDS is much more on the user side. That's how I would see it, at least.
But I heard a little bit of a contradiction there, right? So I agree that there's two possible uses, right? So one is, again, validation, right? So make sure that the fire rating is in the right range. But the other is, I don't want fire rating in my file at all, because that's extraneous information. Then that modifies your output, right? So that's a different use.
Angel, I mean, the use of the prohibited clause, I think it's a rather a seldom case. I mean, you could think of prohibited as the other way around, as the remainder of what's allowed. But usually you would not have prohibited in IDS very often. It's actually more a thing of defining requirements, not prohibiting things. But it's there because there may be cases where it makes sense, So.
I guess I'm concerned about having something that may be used in a way you don't expect. Like I said, I just want to be clear about whether we expect to modify the IFC output or report on it not being what we expect.
I think Björn Stangeland has many times said that, like, he has the vision that you could like use IDS as a query to send the IDS, and then the authoring tool could kind of use the IDS to filter out or filter in, whichever way you think, the information that should be in the IFC file. I don't know how that would work in practice, but that's at least a vision that Björn has brought up several times.
But I mean, that's exactly what Peter Kompolschek has been showing in his example. I mean, he's been using IDS as sort of a filter to find out which elements have been built in a certain time frame. So it's you can think of it as a filter as well, you know, in a sense, and that can be quite useful because they can be very complex filters if you can build using IDS. But it's just one particular use case of it. I mean, that's not what's originally designed for, but it's a use case that makes sense and can be very, very helpful in practice, working with IFC models, especially in the construction process. I mean, when you go do the accounting and all this kind of things that you now can do with these kind of models.
But in this, in light of all of this, I think it makes much sense, the question that Angel made around the exclusion of possible solutions, right?
The inverse, so to say. Yeah?
Exactly, because in a sense, what we want, I mean, for my own perspective, and I might be wrong or disconnected from the rest of the group, I see this as a tool to kind of enforce good practices that are easily defined between stakeholders at a lower level than the software developers. And so these kind of exclusions might be inserted when they kind of trigger some really bad behaviors. I don't know, the structural or some parties that have nothing to do with walls, they just inject walls in their models and confuse perhaps receiving parties with information that they shouldn't be providing. But this makes sense in a federated context in which the architect has responsibility over the walls, and I don't want to see any walls in the MEP model at all. But again, it's easily defined at the level of the user downstream. And I think we see an opportunity to use this as a mechanism for negotiating information provision at different stages. So rather than, just once all of this information required is made available from somebody downstream, then a BIM planner could sit in front of a table and say, okay, but who am I tasking with providing this information at what stage? And so this kind of allows for a workflow planning, information workflow planning mechanism. And also perhaps helpers when it comes to actually filling in that information to the end user and stuff like that. So we are always keeping an eye on that front. But I agree that this kind of negative of the requirement is a potentially a tricky topic that we need to think carefully about.
We need. Sorry, Peter, we need to wrap up this session quite soon. We've got only 10 minutes left. So if you've got any final comments, please go ahead. And then we need to continue the presentation. Did you want to add anything, Peter?
Yeah, I just wanted to because Stefan was asking what I thought about the IDS in my project. And I feel what I like with the IDS is that you can go from the high flight level to dig into the data. So you start, like, say, for level 1, we just want to have that you as a design team provide us with the information as and not defined, but you have the properties that we ordered. And from step to step, you can see, okay, first we have the property, then you have the property, and it has some content, and then you can check the content, so you can dig into the data. And so you can really easily dive into your IFC models and make the quality checking very easy and very transparent for the whole design team. This is what I like on this IDS concept. That's all I want to say. Thank you.
Thank you, Peter. So I'll just start sharing this screen again. And the next one is about IDS 0.5.10 class diagram. Robin, did you want to talk about that?
Yes, so this was a diagram that Lucas put together trying to encapsulate his interpretation of where we are with IDS. I think this is the current model. So this is available from the I think this is from the GitHub, but we've got the links that will allow you to dig around in all this sort of information in the final slide in the presentation. Next, Sara. Okay, and we mentioned the homework. As issues emerge, we've got weekly meetings of the IDS group, and as we go and identify issues, then Leon especially, but other people are coming out with use cases that we can actually use to check. So this is one of the most recent ones that Leon put together, where he's got the XML as well as the IFC as well. Okay, Sara. Okay, these are the current issues. As you can see, we've had 38 issues we've closed so far in the project, and these are some of those that are open and under active discussion. So it's all fairly active, as I said, weekly meetings, and we discuss something different each time. We try to find something interesting to put in that demonstrates something, but then we're also discussing how we can close off the implementation issues that emerge. Next, Sara. Okay, so some of the next steps that we personally see, and based on the discussion we just had after the demos, lots of other people have other visions of what can be done. So that an immediate aim is to have some improved demonstrations for the end of March when we have the bSDD forum, and we want to be able to demonstrate what has actually been achieved within IDS. We're both very happy with what's gone so far, considering that we've only been working for less than 6 months. One of the we had lots of discussions about use of regular expressions, for example, to check on data. But after last week's discussion, I mentioned somewhere about needing to use regular expressions for dates. And another alternative would be to also look at the existing services within the operating systems, where they've already implemented ways of mapping dates automatically between different calendar systems. So perhaps we need to look a bit more widely to meet that initial goal about using pretty much industry standard tools. And what we're basically doing within the project is incrementally addressing issues as they arise in the software. And one final one that might be a little bit more ambitious, Sara. In the last example Leon put together was about wooden windows, and it had lots of terms in there that are Dutch. And while one of the goals of IDS is to actually exploit the bSDD definitions, and one of the things that I'd like us to start considering is how we can actually have those embedded in our files, and so that we can actually internationalize the terms much more readily within information exchange. So that's something that would be much further in the future, I would expect. Next, Sara. Okay, so here's the links to the IDS project page where the goals of the whole project are put together, the GitHub site and the Slack site where a lot of the information that we've got in this presentation is, and a lot of other information as well. So if you're not playing with us yet, then and you're interested, then please have a look, see what we're up to, and join us on Tuesdays when we have our weekly meetings. So if we've got a little bit more time, Sara, we could just have a little bit more discussion if people want to bring up additional points.
We've got about 4 minutes left. Leon, should we continue the discussion or should we start the new session?
I think it's a nice wrap up, and we will give Johan an additional couple of minutes for his presentation. Thank you all. So I see that Sara is still putting out the links. I think there's actually a scope documentation on the GitHub website that might clarify some things, also with examples of design requirements that are out of scope, but transforming them into information requirements that are in scope. So that might help. And otherwise, yeah, the Slack channel has a specific IDS channel as well. So we're really looking forward to further input on this. Thank you all. Thank you, especially Sara and Robin, who are, I think it's already tomorrow where you are, guys.
Yes, yeah, we're so far ahead of you.
Yeah,
now.
thank you. Thank you so much for this presentation from the future. I really appreciate your commitment on this.
Thank you.
Thank you all. It's been a pleasure working with you all.
All right, then next one is Johan. I see your camera is already up. Thank you. If you want, you can start sharing screen, Johan. Does your sound work?
Yeah, can you hear me?
Yeah, perfect. Thank you. So yeah, also just a quick introduction, because the theme of this session was validation, but IDS and the bSDD validation servers are quite different, I would say. So maybe just a bit of context. So IDS is really about checking information delivery specifications and defining them inside IFC. The bSDD validation service is twofold. One is checking against the formal schema, which is a strong request from a lot of software vendors that we have one definitive way of telling users if their file is correct IFC or not. And the other purpose, and that's the reason why it's called bSDD validation service, is to check information consistency against what is defined in bSDD. So there is a relation with IDS, which I am very keen to go into deeper at some point. But for now, these two things are being developed relatively separately, but still with the vision to integrate them at some point, as you already saw in the previous IDS presentation as well. So I think that what it exactly means to check information consistency is what Johan will explain in this presentation as well. So thank you, Johan.
Okay, so hi everyone. I'm going to present the progress in the bSDD validation service. So the function of the tool is quite simple. It enables to provide a neutral, transparent validation of the consistency of a file. So this is the main purpose regarding elements with respect to the bSDD. The goal is to validate each element which are classified. And when I will be using this term classified in the presentation, it doesn't mean secret. It means that there is an external classification reference that is targeting this instance. So here you can see on the screen the result, without waiting more, of what you could expect from uploading a file on the bSDD validation service, and by choosing a different type of checks that you want. So you can check the syntax, the schema, and the MVD, not for now, but and the bSDD, and view report and have some information about your file. So first, let me introduce the tech stack used for this project. So we are using the IFC pipeline, which is at its name says is a pipeline to process IFC file. It's available on GitHub, and you can have this pipeline for a different purpose, for viewer or for also validation. And here we're using it only for validation with associated checks. So we're using Docker Compose and Docker. So Docker Compose is enabled to have the different services that the application is providing. So we have a database service, a worker service, and the front-end service. And the application is developed using Flask on the server side with a queuing mechanism with Redis. And we're using Lark Python for parsing and validating the syntax, the IFC syntax of the file, and IFC OpenShell Python to extract information about the file and do the other checks. So the IFC pipeline workflow, so as you can see, everything works through the Flask server. So you can request some action from the server, so the validation of the check, and everything is done through a worker mechanism where there are the 3 checks that can be run, and the bSDD check is going to request some information from the bSDD API, and then it will store the results of the check in a database that can be used to display the result of the checks from the user interface. So the checks available in more detail. So the first one is IFC syntax. So it consists in parsing with Lark with respect to the IFC grammar, the IFC file, and it records the error message. So there are 2 possible outcomes. Either your parsing was successful, either it was not. And if it's not, the error message is stored in the database and can be retrieved in the user interface. Regarding the IFC schema, it enables to check the optionality of attributes. So, for example, there will be an error if an attribute which is not optional is not present for the instance. And it also checks attributes types, cardinalities of aggregates and inverses, and select and enumeration items. And finally, bSDD, the main point is first you get the classification from bSDD, and you get this classification, but I will come to that later, from the instance, and then the IFC classification, reference, etc. And then you validate the consistency of the instance with respect to what the classification requirements are. So the check procedure for this bSDD in more detail. So first you retrieve the IFC classification reference of an instance, and you look at the location attribute of this IFC classification reference to get the bSDD classification URI. And thanks to this URI, you can call the bSDD API and get a JSON object that represents the classification in the bSDD. And then you can get the specifications from the classification object, which are stored, we'll show you later, in classification properties key. And you can, at the end, extract information and produce validate output. So it works as follows. First, on the bottom left, so the check program works as follows. So you iterate through the IFC real associates classification instances. And for each of this classification, instance, you have related objects and you have classification reference. So from this classification reference, as I was explaining in the previous slide, you can use the location attribute, which provides the URI of the classification object in the bSDD. And once you are in the bSDD, you can have the classification properties. And then for the classification properties of this classification, you can validate each of the instance concerned by this classification. So currently, those are the constraints imposed by bSDD on model. So you have the classification properties object, and you have several keys in there. And the one that you can see highlighted are the one that the instance properties are going to be checked against. So the name, data type, predefined value, a property set. And we say that an instance or a model is consistent because if a model has, so this is from a certain classification, which is 2222 from the Dutch building code NSFB. And from this classification, we have classification properties, and we have two classification properties. And it is consistent if the instance which is classified as 2222 in the NSFB domain as this property, so as a property set, preset whole common in which there is a property load bearing, and the predefined value should be true if this is an instance of classified as such. And the same for its external. There are special cases, though, that you can encounter when using the validation service. So first, you can have no classification in the file. So that means there is no IFC classification reference instances or IFC classification, and you have no relation regarding the classifications. You could have also, you can encounter the case where you have no URI in the location attribute of your IFC classification reference, or you have an invalid URI that is not recognized by the bSDD API. You could also have no classification properties in the classification objects. So let's say you have classification, IFC classification, etc. instances in your file, you have the URI, and you arrive at the bSDD API, and finally there is no classification properties. So in that case, this is a valid check because there is no requirements. And this is the result that you can obtain after uploading and checking your file. So I will show a live demonstration in short time. But here you can see some general information about the file. So you can see the name, the date it was uploaded at, file size, and you can have a number of geometries and properties to have a feel of how big your file is, how complex it is. You can see the IFC schema, authoring application, etc. And the overall result of the validation. So here we have a file that has been checked against syntax schema and bSDD. Blank square means not checked. So it passed the syntax test, not the schema one, and the bSDD. And on the right, you can see the syntax, you can see, sorry, the different parts of the checks, the different results. So for the syntax, it is valid. For the IFC schema, it is not valid because, yes, there is an attribute that is not optional. And here you can see the bSDD consistency result. And you see each of the requirements that I presented earlier. So the IFC entity type, property set, property name, property value type, and property value. And the first four requirements passed, but not the last one, because it is expected to have the property load bearing true, and what is observed in the file is false. So now I'm going to demo. So validation service, you can see the interface there. So you can go to the dashboard, or you can upload some file. So let's go to the dashboard. And you can see here some files that I've uploaded and checked. What you can do from this dashboard is you can change the license of your file once you upload it. You can add production hours. You can add additional details also, and you can see directly after the checks the results. So here we have a duplex classified file. So this is a synthetic file that I have. So that means I have put classification references and I've generated this file programmatically. And when I click on view report, I can view the report. And there you can have this hierarchical structure when you have the domain and the classification reference, sorry. And you can see the different results of the checks for bSDD. There is also, for example, this file where I put S character, so where it shouldn't be. So there is a syntax error. So you can see that it is not valid regarding syntax. And the schema and bSDD consistency hadn't been checked on this one. Also, let's see another example. So for this one, duplex classified. So what I did is I did several checks. So the syntax, the schema. So here it's a synthetic file. So I may have forgotten to put that correctly, but still you can see the example and you can see the results. So everything seems nice, but not for this one. So for this instance, this instance is classified as 22 from this domain. And what was required was an IFC wall, and what's observed is an IFC door, so it is not valid. And yes, I had put a preset wall commode and load bearing for an IFC door. It's just a corrupted file to check how good the validation is. You can also download the file that you uploaded and you can return there. You can, oh, sorry, sometimes. Yeah, I think that's all. Yeah. Okay. So the next steps for this project would be to improve the user interface, and I think exporting the report in PDF format would be really valuable, and add a replay feature, so to recheck something that you have already checked that is visible in your dashboard. So thank you, and don't hesitate to try this validation service there. And yeah, I hope it will be free from bugs, but if you encounter some, please share them with me. Thanks.
Thank you, Johan. Just to add a couple of additional comments. So I think we are approaching a stage where we are open for beta testing. So if any one of you is interested in testing this, please let us know. There's this email from Johan, but we also have validate.buildingsmart.org that you can email if you're interested. And maybe a second comment that might interest you. This is, as you probably saw, all is based on IFC OpenShell, and all of the code also for this validation service will be shared and made open source available. So we're really moving towards a validation service that can be validated by third parties as well. It's not a black box. It's really trying to make a white box service here. So with those two additional comments, maybe we already covered a couple of questions. Are there any other questions? I guess it was a long day, or it was a very comprehensive and nice presentation by Johan. Let's settle on the ladder. So if there are no other presentations, then we're going to give you back a quarter of an hour. Let me try to share my screen to give you a hint of what's happening tomorrow. So tomorrow we're starting at 9 again, same time as today, 9 European, with the bSDD Q&A. This is pretty much unprepared. So this is Eric Breuss, the developer of the bSDD, coming in and ready to answer your questions. We have one slide on how the bSDD content needs to be mapped to IFC. I think that hasn't really been shared yet so far, but that is important for implementations. And I expect that we will also have a couple of ad hoc presentations. I saw one from Arka last Tuesday that was pretty impressive, so I guess we have time for that tomorrow as well. But if anyone is interested in bSDD, in the API, in how you could get data in, tomorrow is really opening up to all kinds of questions, quite a ad hoc session. So there's only 2 PowerPoint slides prepared for that. So if you have any, please dive into it tonight or tomorrow morning, depending on the time zone that you're in, and feel free to join that session. There's also, after the break at 11, we had an open house. We had an invite for presentations that might be interesting. And we got one from Arka on transforming any kind of IFC data into valid IFC 4.3. So if the bSDD session ends earlier, we will probably do this Arka presentation earlier as well. So if you're interested in that, make sure that you're a little bit on time in the case that bSDD session stops earlier. So that was it for today. Just to remind you again that all of these sessions have been recorded. We will publish them on this link, buildingSMART.org/General Assembly of Implementers. You will see all of the previous videos from our previous sessions as well. And we'll also put a link to that on the forums. So with that, I thank you very much, and I'm looking forward to see you again tomorrow.